Good morning, friends. I'm Dr. Vidya, back to you with the remaining part of air pollution. So, in the last lecture of the air pollution, we have studied about what is meant by pollution, what are the different types of pollutants, how to identify the major air pollutants and minor air pollutants, what will be the sources, and as per the sources, as per the different types of sources we have studied in the last lecture. Now we are going to focus towards the next part, that is the metrological parameters, or we can say basically we are going to study about the dispersion of air pollutant. In the last lecture, one fact I told you that wherever you want to control the air pollutants, one must control at the source. Why should control at the source? Because once that pollutant is going to be emitted into the atmosphere, it is quite difficult to catch it, identify it, and separate it out from the volume of air. So we should know that the air pollutant must be controlled at the source. Though this is a fact, is it possible to control entire air pollutants at the source? It may be possible up to some extent. I'm not saying 100%, up to some extent in the case of point sources. In the case of point sources, but it is not possible in the non-point sources. What is meant by point sources and non-point sources? Point sources are the pollutants which are emitting from a specific point into the atmosphere. For example, stack of any industry or chimney of any industry. That is the point source. And the non-point source are the sources which are emitting from a particular area, particular line, particular area. You can take the bus stand, railway yard, is it? So same way, if you are going to consider the line source, you can consider the highways, railway track, aircraft lines. So from that, the continuously air pollutant are going to emit for a longer period and longer distance. So it is quite difficult to control them from in a area source. Then what is to be done with this? As I told you, we have to control at the source, but still there is a highly possibility to have the air pollutants into the atmosphere. Along with these anthropogenic sources, there are some natural activities are also there which are going to create the air pollution. Flowering of the plants, then cyclones. During cyclone, huge amount of dust is going to be emitted. Then uneven roads in a country, these are contributing huge amount of dust particle emission during the transportation. Then earthquake, volcanic eruption, such natural activity are also going to be contribute a lot for the air pollution. Then what we have to go for if they are emitting into the atmosphere? Okay, so for that, specifically from a particular source, when the air pollutants are going to be emit, it's a dispersion is very important factor. Why dispersion is important factor? Suppose a sugarcane industry you can take, and there is a chimney to that sugarcane industry, and from that chimney the air pollutants are going to be emit. In spite of that, they have installed many different equipments to control the pollutants. Up to 70% maybe they are controlling before coming to the chimney, but still there is an emission of air pollutant up to 30% into the atmosphere, and that 30% is also huge amount. So for that purpose, when it is emitting into the atmosphere through the chimney, at that time, if it is depositing continuously in the nearby 5 km periphery of that industry, so what will happen? That 5 km area after 1 week or 1 month is going to die, because they are going to get affected with the pollutant continuously, is it? Instead of that, if the pollutants emitting from the same chimney starts dispersing for a longer distance from that particular spot, so what will happen? It will change in concentration. A less amount of particle will fall down near the 5 km periphery, and such a way that it will go to disperse in a long distance. Means the concentration of air pollutant into the atmosphere is going to be dilute, and there is a issue with the air pollutant. If one inhales up to the threshold limit of that air pollutant, we may not get affected, but beyond that limit the person may get highly affected with the air pollutant. Is it? So with respect to air pollution, one more fact I would like to tell you, that I think I might have explained to you in the first lecture, that regarding air pollution, we cannot identify this air is polluted or non-polluted many of the times, and we cannot survive more than 30 seconds without breathing. So once you are there in that air, you should breathe, and the pollutants are going to be inhaled by us and deposit into the lung. Around 16 kg air we breathe every day, and you can imagine how much amount of pollutants are going to be inhaled by us. But up to certain limit we can digest, our resistance power will work, but after certain limit it will start killing us a different way. Our organs are going to be killed. Is it? So that's why for any project, whenever you are going to start any project, you should study the metrological parameters first. Or for getting the permission to start the new project, one should get the permission from local authority, local body, then state body, then central body. It depends upon the size and the production of that particular industry. So if we are going to install that project, you should find out, you should go for these permissions, and while getting the permissions they will ask the metrological parameters analysis. With the help of outsourcing, or you can go with your own, that for the metrological parameter analysis, and that metrological parameters analysis will be able to brief how much this industry is going to affect in the residential area, residing area. Is it? So what is this? We are going to see. Air movements influence the fate of air pollutants. So many study of air pollution should include a study of the local weather patterns, that is the meteorology. On the other hand, when strong turbulent wind blows, pollutant disperse quickly, resulting in lower pollutant concentration. So what are the major or main meteorological parameters in this field that I am going to tell you? These are nothing but the wind speed and wind direction, air temperature, air pressure, air humidity, precipitation, haze and contents of the air, solar and terrestrial radiation. These are the major meteorological parameters. How these are going to be help us to identify whether the industry is going to project is going to be affect on the residential area or not. Okay, now first one is the wind direction and wind speed. Wind direction and wind speed tells about which area and how much is getting to be affected. So minimum wind speed should be 15 km per hour average, yearly average of that nearby that particular project. Meanwhile, it will take the pollutants a long away, and the continuous effect on the residential area will not be there. Then the wind direction. Wind direction also be helpful to identify whether for a longer period in a year the air direction of wind is same or it is going to be changed, or many of the time in a particular area there is one side is there is the residential area and another side may be the industrial area, or it is a barren land. In that case, if the wind direction is towards the residential area for a longer period, you may not get the permission. But if the wind direction is changing continuously, in that case there will not be problem, because our final and ultimate aim is to dilute the concentration of air pollutants. So if the direction is going to be changed, there will be a dilution of air pollutants. Then the next one, air pressure. Air pressure is very important because wind blows as per the pressure. From high pressure to low pressure, wind starts blowing. Change in pressure will make wind to blow, and meanwhile the concentration of the air pollutant starts diluting. Then the precipitation. Precipitation is also very important and useful parameter to reduce the air pollutants. Okay, I will ask just one example. Have you observed yesterday night there is a very heavy rainfall, and in the morning when you woke up and go outside your gallery, what you will feel? It's a very cool, calm and fresh air. Why it is happening? Because the atmospheric pollutant has been dropped down along with the precipitation towards the ground surface. Meanwhile, the atmospheric air is very clean and fresh. So, this way the precipitation helps us to drop down the air pollutants, though it is a gaseous air pollutant or particulate matter. Everything will drop down with the precipitation. Then the humidity. Humidity is also very important factor. If the humidity is more, a dispersion of pollutant will be less, but at the same time it will start clogging together. Pollutants starts clogging together, and it will start settling down at the surface of the ground because of increasing the mass. They will not be able to float. They will immediately start falling down on the surface. So this way the metrological parameters are going to be help us to identify whether the pollutants are affecting or not. Okay, now we are going to study the dispersion of air pollutants, and this dispersion for a particular point source we can study with the help of plume behavior. So what is mean by plume? Just now I had given to you an example of the sugarcane industry, and in that sugarcane industry there must be a chimney for the emission of air pollutants, and from that particular chimney a mass of air pollutant is being emitted continuously until that industry is working, is it? So that pollutant takes a particular shape while moving in the atmosphere, and that shape is nothing but the plume and its a behavior. So its a behavior is totally depends upon the atmospheric conditions. Atmospheric conditions. So we will see what is the plume and its a behavior. Plume refers to the path and extent in the atmosphere of the gaseous effluents. The behavior of a plume emitted from any stack depends on localized air stability. Dispersion of air pollutants is governed by the wind speed and environmental conditions, as I told you. Now we will see different types of plumes. There are 6 types of plume. As per its shape we have given, there are the names. First type of plume is the looping, second coning, fanning, lofting, fumigation and trapping. Okay, these are the different types of plume behaviors, plume shapes. And now we are going to study which type of plume, what area is going to be affect. And plume behavior depends upon the environmental conditions. So first we will see looping plumes. It is a type of plume which has a wavy character. So just see first a figure. This is the looping plume. Loops are going to be observed. So here I will magnify a little bit to understand where is the source. So this is the source, this is the industry and this is the source. Now you can see Here arrow has been shown to identify the direction of flow of air pollutant, is it? So here the pollutants are going to be emit and flow into the atmosphere, and while blowing it is taking a wavy type of structure, ups and downs are there, is it? So it happens due to the highly unstable in atmosphere. It is a type of plume which has a wavy character. It occurs in a highly unstable atmosphere. The high degree of turbulence helps in dispersing the plume rapidly, but high concentration may occur close to the stack if the plume touches the ground. Is it? So immediately it may touch to the ground, and the people may are surviving in that nearby area may get affected. But still, if there is a continuously blooming, it will take pollutants a long distance, towards the long distance. Then the coning plume. It is the type of plume which is shaped like a cone. You can see here figure, it is shaped like a cone. It happens when there is the velocity of wind is greater than the 32 km per hour. However, the plume reaches the ground at greater distances than with the looping plume. Then the fanning plume, it is a type of plume emitted under extreme inversion condition. What is meant by inversion condition? That I will tell you first. You might have heard about the lapse rate, altitude, these words you may be knowing. Still I will explain it. Altitude is nothing but the height from ground surface towards the atmosphere. So in the atmosphere there are the different layers, is it? What are these layers? The troposphere near the ground, then stratosphere above the troposphere. Above the stratosphere there is a mesosphere, and the last one is the ionosphere. So in the ground troposphere, almost 0 to 12 kilometer distance is identified as a troposphere, and that layer is very important because all the biotic organisms are surviving in that area. So I was telling about you the lapse rate. What is the lapse rate? Generally, decreasing temperature with increasing altitude. You can take example of hill station, okay, and at the sea level. So at the sea level we feel warmer, but when you go up towards the hill station there is a cool. Why it is? It is a natural phenomena. Increasing altitude, decreasing temperature, that is the natural phenomena, and this natural phenomena is known as the positive lapse rate. Understood? Now what is the negative lapse rate? When the temperature is going to be decreased with increasing altitude. Some of the area it may happen, and because of the air pollutants or the environmental conditions. So the increasing temperature with increasing altitude is known as the negative lapse rate, is it? And that negative lapse rate condition may create the inversion conditions. We'll come to the inversion now. Inversion is nothing but the formation of stagnant environment. There will not be the vertical movements in the of the wind. So why this happens? Vertical movements are going to be stopped. Why? Because there will be different types of inversions are going to be occur. So the two main types of inversions I will explain you. The first one is nothing but the radiation inversion. Radiation inversion, it generally occurs near the ground. When it occurs? During the winter season or during the night. Early morning you can observe there is a radiation inversion formed. During the night, during the day what happens? Solar travels their energy towards the earth, and it will heat the things on the earth body. During the night earth starts releasing temperature, and because of that the air near the earth surface is getting warmer, and above that the air will be cool because there is no radiation during the night. So till the morning what happens, that the warmer air near the earth surface getting covered with a cold air above that layer, and because of this phenomena it will not allow to have the vertical movements of the air. That is known as the radiation inversion, or we can say it is also known as surface inversion. Then when it gets breakdown, it will get breakdown when there is the next day morning sun rises and the cold layer above the warmer layer is getting once again warmer. Then there will be a vertical movement of the air pollutants, and then it will start normal movements of the air, vertical as well as horizontal. Okay, that is about the radiation inversion. Now another type of inversion is the subsidence inversion. Radiation inversion usually occurs near the earth surface, and radiation inversion usually occurs above the at the top of the troposphere or above the tropospheric layer, we can say. So it is a type of plume emitted under extreme inversion conditions. The plume under these conditions will spread horizontally, but little if at all vertically. Therefore, the prediction of ground level concentration is difficult here. We cannot predict where is going to be fall down. You can see figure here. A straight line it is moving. How long it will move straight and when it is going to be drop, it will be quite difficult in this case. Then the next one we are going to study, that is the lofting plume. Lofting occurs when there is a strong lapse rate above the surface inversion. Under this condition, diffusion is rapid upwards, but downward diffusion does not penetrate the inversion layer. Under these conditions, emission will not reach surface. So you can see here lofting, such type of phenomena will be observed in a lofting. Then the fumigation plume. It is a phenomena in which pollutants that are emitted into the atmosphere are brought rapidly to the ground level when the air destabilizes. Here when there is a subsidence inversion above the ground layer, so it is not close to the surface. Because of that, there will not be the movements above the stack height. So below the stack height, entire pollutant starts mixing, and because of that, the residual people get affected in that case. Now we'll see the trapping plume. This refers to conditions where the plume is caught between inversion and can only diffuse within the limited vertical height. The lofting plume is most favorable for air to minimizing the air pollution. The fumigation and trapping plumes are very critical from the point of ground level pollutant concentration. So this is the example of the trapping. So for your understanding, I have drawn all these figures once again here on one page. Okay, this was about the dispersion of air pollutants. So we can, with the help of that study, we can identify which area is getting affected with the air pollutant emitting from a particular source, or we can say point source. This is only with respect to point source. Now we will see the general effects of the air pollutants on. General effects of air polluted atmosphere can be classified into following 5 heads. What are these 5 heads? Effects on certain material, effects on plants, effects on animals, effects on human health, effects on physical features of the atmosphere. So we will see one by one. So first is nothing but the effects on certain material. Certain material in the sense constructions, buildings, any kind of material, non-living thing available in a atmosphere. There will be abrasion, deposition and removal, corrosion, direct chemical attack, indirect chemical attack, discolorization, weakening of the structure you may observe with the materials. That will be the effect of air pollutant. Is it? You might have understood. Then we will take the example of uh, Taj Mahal, well known example, which is getting affected due to the continuous effect of air pollutants on that. So that is getting blackened because of the air pollutant effect. So this way the pollutants are going to be affect on the materials also, not only on the human. Next, effects on plants. The air pollutants also affect on the plants. So how, what way these are going to be affect on the plants, that we will see. The first one is the stomatal clogging, bleaching, reduction in growth, reduction in crop yield, bronzing, necrosis and chlorosis. These are the common effects we observe on the plants. Stomatal clogging. So stomatal clogging, what happens during the air pollution? We say usually plant the trees for the control of air pollutants. Is it? So what happens exactly? If it is a gaseous pollution, I can understand the plants are going to be absorb it. But with respect to particulate pollutants, that carbon monoxides, carbon particles or the dust particles, various sizes of the dust particles, what happens with this? When the plants are there, such type of pollutant deposit on the surface of the leaves of the plants. When that surface of the plant's leaf get covered with the dust particle, there will not be the pores of the plants will get blocked and there will not be a respiration process, and because of that stomatal clogging starts. Ultimately it will reduce its growth and finally we will get less yield from that particular crop. So chlorosis is also effect for the because of the deposition of pollutants on the surface of the earth, surface of the plant's leaves. So how chlorosis? We know photosynthetic activity. The plants absorb the carbon dioxide and release the oxygen, and in presence of sunlight it is going to be prepare their own food, and for that purpose they need the chlorosis present, chlorophyll content in their body. Is it? Because of the presence of chlorophyll content in their body, they can prepare their own food in with the help of photosynthetic activity. But if there is a deposition of the dust particles on the surface of the leaves, there will not be a photosynthetic activity smoothly functioning, and hence the chlorophyll content in their body starts reducing. That is known as the chlorosis. So this activity finally is going to be die that plant or kill that plant or reduce the yield capacity of that plant. Then the bleaching. Bleaching is nothing but the change in color. Usually the color of plants is the green because of the chlorophyll activity, chlorophyll presence and the photosynthetic activity. But sometimes due to the air pollutants, it starts bleaching, sometimes marginal bleaching or the entire leaves bleaching, converting that leaf into yellowish color. Then the bronzing. Many of the times you might have observed a brown color spots are being identified on the leaves of the plants. That is the bronzing. One disease, necrosis. The plant's leaves starts turning towards the backside, river side, towards the ground side. So there will be a less exposure with the photosynthetic activity and reduction of yield will be there. Then the effects on animals. Animals are also getting highly affected with the air pollutant, and these are nothing but the vomiting, uneasiness, loss of appetite, paralysis of digestive system, diarrhea. Then the effects on human health. So many of the time we face here while dusting of our own house, there is the emission of dust, is it? And that is going to be create ear, nose and throat irritation, is it? Normal people also will help. Though those are asthmatic people, they will feel asthmatic. Those are having allergy, they are also getting suffering. But normal people also feels ear, nose and throat irritation due to the air pollutants. Then irritation to the respiratory tract is also going to be occur. Chronic pulmonary disease, asthmatic attack, skin cancer, lead poisoning, bone fluorosis, increase in mobility and motility rate, shortening of lifespan, and genetic effects. So, I would like to give you an example with respect to genetic effects. So, today is the 2020 in Bhopal in 1984. I think in 1984 exactly, I don't remember, but it is 1984. In the 1984, there was a MIC incident, leakage of the gas through the industry, and the people were getting died. So same, when the people were getting died that time, but still genetical effects are being observed till date after the 36 years also, is it? So that air pollutants highly affect for a longer period genetically. Then the effects on physical features of atmosphere, mainly visibility. So the many of the accidents happens because of the visibility issue. Visibility changes, reduces the visibility of the atmosphere due to the presence of atmospheric air pollutants. So many of the time we observe the smog. We observe smog or the fog. We say usually it is fog, but it is smog. Smog is nothing but the presence of smoke plus fog together and reducing the visibility of that particular area. Then effects on urban atmosphere and weather condition, effects on atmospheric constituents. So such a different effects are going to be observed on the human body, along with the atmosphere. So we will stop here today, and I will say thank you to everybody and have a nice day. Thank you.